Hello student, welcome to my channel Learn Physics. Today I will be discussing a one-shot video of motion in a plane. Now today's discussions are scalar and vector, types of vector, addition and subtraction of vector, resolution of a vector, that is rectangular component of a vector, representation of a vector in terms of unit vector along the coordinate axis. Finally, the displacement vector, velocity, then a displacement vector, velocity vector, acceleration vector in a plane, then a relative velocity, then a river crossing, and finally projectile motion from a height and from the ground, and all the numericals of ncert physics and the ncert numericals related to these topics. Okay, now let's start. First of all, scalar quantity and vector quantity. Some quantities like speed, distance, energy, etc. have only magnitude. These physical quantities which has only magnitude are called scalar quantities. And the quantities like displacement, velocity, force, these physical quantities have both magnitude and direction. These physical quantities are called vector quantities. Vector quantities are represented by a line segment with an arrow. The length of line segment represents the magnitude of the vector and arrow represents the direction. Now types of vector. Now look at this. This point is called initial point of the vector and this point is called the final point. Look at this. This is the head, this is the tail. Okay? Now types of vector. First of all, collinear vector. Vectors are on the same line or parallel lines are called collinear vector. The angle between two collinear vector is 0. Now coplanar vector. All the vector in a given plane are called coplanar vector. Okay? Then now unit vector. Unit vector. The vector of unit magnitude is called unit vector, or if a vector is divided by its magnitudes. Look at this. This is the vector and this is the magnitude of the vector, or it can be also written as a vector by a, then it is called unit vector. So unit vector is dimensionless. Okay? Now null vector. If the initial and final point of a vector are coincided, then magnitude of the vector is 0. This vector is called null vector or zero vector. Look at this. A vector minus a vector equal to zero vector. Okay? As null vector has no magnitude, so we can't specify its direction. Okay? Now equal vector. Two vectors, suppose a vector and b vector are equal if they have same magnitude and direction. Okay? Next, opposite vector. Opposite vector. Two vectors are equal of magnitude and opposite in direction are called equal vector. Suppose this is the a vector and this is the c vector. So look at this. A vector and c vector are equal in magnitude but opposite in direction. These two vectors are called opposite vector. The angle between two opposite vectors is 180 degree. Okay? Understood? Next, vector addition. First of all, triangle law. If two sides of a triangle represents two like vectors both in magnitude and directions, suppose this is the a vector and this is the b vector, two like vectors represented by the two sides of a triangle, then the third side taken in reverse order represents their sum. Look at this. This is the third side. This side represents their sum, that is A vector plus B vector. This vector is called resultant vector. Okay. Here ON vector is equal to OM vector plus this is the MN vector. So here R vector is equal to A vector plus B vector. Okay. Now parallelogram law of vector addition. Two adjacent sides, suppose OM and OM dash represents two like vectors, suppose A vector and B vector represents two like vector, both magnitude and direction. Then the diagonal passing through the point of intersection of the two sides represents their sum or resultant, that is R vector equal to A vector plus B vector. Okay. Now look at this. From this figure, look at this here, OM vector plus, now look at this here, ON vector is equal to OM vector plus OM dash vector. Now OM dash vector equal to MN vector. So look at this is the OM vector plus MN vector, because look at this side and this side are parallel and equal. So look at this just like a triangle law, that is A vector plus B vector. Therefore triangle law and parallelogram law are identical law, only they differ by their statement. Okay. Now we have to prove the commutative law of vector addition. Now look at this, from triangle, look at this, from triangle OM dash N. Here look at this, ON vector is equal to OM dash vector plus M dash N vector. Okay. So look at this. So look at this is the B vector plus A vector. Okay. Now this is the R vector. Therefore look at this equal to this. Therefore look at this equal to this. So look at this here, B vector plus A vector equal to A vector plus B vector. Okay. Now we have to calculate the magnitude and direction of resultant vector. Look at this, a perpendicular NP is drawn on produced OM. Look at this, NP is the perpendicular and this is the base. So NP by B, this equal to sine theta. Therefore look at this, NP equal to, this is the B sine theta. Okay. Now look at this, again this is the base and this is the hypotenuse. So look at this is the MP by B, this equal to cos theta. Therefore MP equal to, this is the B cos theta. Okay. Now from this triangle ONP, this is the hypotenuse, this is the perpendicular and this is the base. So look at this is the ON square equal to OP square plus this is the PN square. Now ON square means R square. Now look at this, OP square, OP is the A and MP is the B cos theta. So this is the A plus B cos theta. This is the whole square. Now PN equal to B sin theta. Look at this is the B sin theta. This is the square. Okay. Now look at this is the R square. This is the A square plus 2AB cos theta plus this is the B square cos square theta plus B square sin square theta. Okay. Now here look at this, B square cos square theta plus B square sin square theta. So this becomes B square. So therefore A square plus B square plus 2AB cos theta. So R equals to root under of A square plus B square plus 2AB cos theta. Okay. 5 is the angle made by resultant vector with A vector. So look at this, tan phi is equal to, look at this is the NP by OP. So NP equal to B sin theta divided by A plus B cos theta. Okay. Now special cases. When two vectors are in a line, look at this, suppose this is the A vector and this is the B vector. So theta equal to 0 degree. if theta 0 degree, look at this, cos 0 equal to 1, so r becomes a square plus b square plus 2ab, that is a plus b whole square, that is a plus b whole square root over, therefore this becomes r max, so this becomes, so r max equal to a plus b. In the same way, when a vector and b vector are in opposite direction, okay, are in opposite direction, theta equal to 180 degree, okay, if theta 180 degree, cos 180 degree equal to minus 1, so this is the a square plus b square minus 2ab, so this becomes a minus b whole square root under, so look at this, r minimum, this equal to a minus b, okay. Again, when theta equal to 90 degree, that is, look at this, this is the a vector and this is the b vector, then look at this, cos 90 equal to 0, so r becomes root under of a square plus b square, okay. Look at this, if a vector equal to b vector, look at this, if a vector equal to b vector, then this angle phi, then this angle also phi, so look at this, theta equal to phi plus phi, therefore theta equal to 2 phi, therefore phi equal to theta by 2, therefore the resultant, look at this, the resultant of two equal vector bisect the angle between them, look at this, here phi becomes theta by 2, look at this. Now vector subtraction, look at this, if b produced in opposite direction, okay, so this becomes minus b vector. Now this is the a vector and this is the b vector, so angle between them, look at this, the angle between them is 180 degree minus theta. Look at this, the vector subtraction of a vector and b vector is the addition of a vector plus minus b vector. So look at this, here s becomes root under of a square plus b square minus plus 2ab, this is the cos 180 degree minus theta. So look at this, this becomes a square plus b square minus 2ab cos theta, and tan phi becomes, look at this, tan phi becomes, this is the b sin theta divided by a minus b cos theta. Understood? Now special cases, when theta equal to 0 degree, okay, that is vectors are in collinear, then look at this, s becomes a minus b. When theta equal to 180 degree, look at this, if theta 180 degree, this is the minus 1, so look at this, s equal to, this is the a plus b, this is the s max and this is the s min. So subtraction minimum when two vectors are in same direction, and subtraction maximum when two vectors are in opposite direction, okay. Now we solve a numerical. Now look at this, ncert numerical 4.6. We have to prove modulus of a vector plus b vector less than equal to modulus of less than equal to a plus b, greater than equal to a minus b, and modulus of vector subtraction greater than equal to a minus b and less than equal to a plus b, and under what condition the equal sign arrive, okay. Now look at this, first of all we know r max, look at this, r vector equal to a vector plus b vector. So look at this, a vector plus b vector modulus is equal to r. Now r max equal to a plus b, and r minimum this equal to a minus b. So look at this, r, that is magnitude of a vector plus b vector, lies between r max and r min. So look at this, r greater than equal to r min and less than equal to r max, okay, understood. Now look at this, here r means modulus of a vector plus b vector, and r min means a minus b, and r max This is the A plus B. The equal sign comes when theta equal to 0 degree, and this equal sign comes when theta equal to 180 degree. Understood? In the same way, look at this S vector equal to A vector minus B vector, and here modulus of A vector minus B vector is equal to S. Now S max equals to A plus B, S max equals to A minus B. So look at this. So S lies between its maximum value and minimum value. Now S equal to modulus of A vector minus B vector. So look at this and this. When it happens, look at this, when theta equal to 0 degree, this equal to this, and when theta equal to 180 degree, this equal to this. Okay, understood? Now next numerical. The magnitude of sum of P vector and Q vector is √3q. That is the resultant. The resultant makes an angle 30 degree with P vector. We have to calculate the relation between P and Q. Now look at this. This is the P vector. This is the Q vector, and resultant R, which is makes an angle 30 degree with the P vector. So from this relation we can write R vector is equal to P vector plus Q vector. Now look at this. This angle is not given. So this formula is not suitable to calculate this sum easily. The easy way to solve this numerical, look at this, angle between R and P are given. So this is the R vector minus P vector equal to Q vector. That is vector difference of R and P is equal to Q vector. So from this relation we can write Q square equal to R square plus P square minus 2RP cos 30 degree. Look at this. This is the cos 30 degree. So look at this here. This is the Q square. R equals to, this is the √3q. So this is the √3q whole square plus P square minus 2 into √3q into P into √3/2. So look at this. This is the Q square equal to 3q square plus P square minus, look at this, 2 cancel out. This is the 3pq. So from this relation we can write 2q square minus 3pq plus p square, this equal to 0. So from this relation we can write p minus q into p minus 2q, this equal to 0. Therefore from this relation we can write p equal to q or p equal to 2q. Understood? Next. Now sine law of vector. Look at this. This is the A vector and this is the B vector. R is the resultant of A vector and B vector. Now angle between A and R is alpha. Angle between B and R is beta. Look at this. Angle between A vector and B vector. This is the 180 degree minus theta. Now the sine law is, look at this, A by opposite angle of A. This is the sine beta. Okay. Now B, look at this, B opposite angle of this. So B divided by, this is the sine alpha, and R opposite angle theta. So this is the R by sine theta is the sine law of vector. Okay. Now a numerical. Look at this. If R vector equal to A vector plus B vector and B equal to √2a, we have to prove that angle between B vector and R vector not more than 45 degree. Now look at this. Suppose this is the A vector, this is the B vector, and this is the resultant R vector. Suppose this angle alpha, this angle beta, and this angle theta. So from sine law we can write, look at this, this is the A by sine beta, this equal to the B by sine alpha. Now here relation between A and B are given. Now put this relation. A by, this is the sine beta and this is the √2a by sine alpha. Now we have to calculate angle between B and R, that is beta. So look at this, here sine beta is equal to 1 by root 2 sine alpha. Now sine alpha never be greater than 1. Okay, therefore here sine beta never be greater than 1 by root 2. Therefore sine beta never be greater than sine 45 degree. Therefore beta never be greater than 45 degree. Okay, understood? Next. Now a rectangular component of a vector. If a vector is resolved in two components perpendicular to each other, then each components are called a rectangular component. Now look at this, this is the R vector. R vector can be resolved along x-axis, this is Rx, and along y-axis, this is the Ry. Angle made by R vector with the x-axis is Rx. So look at this, this is a right angle triangle. So from this triangle, this is the Rx by R, this is the cos theta. Look at this, this is the base, this is the hypotenuse. So Rx equals to, this is the R cos theta. Now this is Ry, so this is also Ry. Here Ry perpendicular by hypotenuse, this equal to sine theta. Therefore Ry equal to R sine theta. Okay. Therefore, a rectangular component of R vector in a direction theta is R cos theta and other component is R sin theta. Will rectangular component of vector greater than vector itself? No, because the value of sin theta or cos theta never be greater than 1. Therefore, value of Rx or Ry always less than equal to R. Okay, now we have to calculate the relation between Rx and Ry. Look at this, this is the Rx square plus Ry square. So this is the R square cos square theta plus R square sin square theta. Now R square is the common, so cos square theta plus sin square theta, this equal to 1, so this is the R square. Therefore Rx square plus this is the Ry square is equal to R square. Okay, understood? Now next, a particle is projected with velocity 30 root 2 meter per second at an angle of 45 degree with the horizontal. We have to calculate horizontal and vertical component of velocity. Look at this, this is the horizontal line, this is the vertical line. The particle is projected 30 root 2 meter per second at an angle of, look at this, 45 degree with the horizontal. Now look at this, the component along the horizontal direction. Look at this, this is the 30 root 2 cos 45 degree, because this look at this, here angle with the horizontal is given, so this component is cos component, so this component is the cosine component and this component is the sine component. So this is the 30 root 2 sine 45 degree. So horizontal component Rx 30 root 2 into 1 by root 2, so this is the 30 meter per second. And vertical component, look at this, this is the Ry, so this is the 30 root 2 into 1 by root 2, so this is the 30 meter per second. Okay, understood? Now next, now look at this, the representation of vector in terms of unit vector along a coordinate axis. Suppose unit vector along x-axis be I cap, along y-axis be j cap, and along z-axis be k cap. A vector whose initial point is O and final point P has coordinate x, y, z. We have to represent OP vector equal to R vector in terms of I cap, j cap, k cap. As the coordinate of P is x, y, z, So component of r vector along x axis is x. So vector component along x axis is x I cap. In the same way, the vector component of r vector along y and z axis be y j cap and z k cap. Therefore, r vector is equal to, this is the x I cap plus y j cap plus z k cap. Okay, now magnitude of r vector. Magnitude of r vector is the length of diagonal of a cuboid whose length is x, breadth is y and height is z. So r becomes, look at this here, x square plus y square plus z square. Now unit vector along r vector. So unit vector along r vector, look at this, r cap equal to r vector divided by modulus of r vector. So look at this, this becomes x by r I cap plus y by r j cap plus z by r k cap is the unit vector along the direction of r vector or parallel to r vector. Now look at this, x by r, if this is the alpha, so this is the cos alpha, y by r, this is the beta, so this is the cos beta, and if this is the gamma, then z by r is the cos gamma. Where, look at this here, cos alpha I cap plus cos beta j cap plus cos gamma k cap, where alpha, beta and gamma are called direction cosines. What is the relation among direction cosines? Look at this, cos square alpha plus cos square beta plus cos square gamma. Look at this, eta square plus eta square plus eta square. So look at this, this is the x square by r square plus y square by r square plus z square by r square. So look at this, this is the r square, this is the x square plus y square plus z square. So r square by r square, this is the 1. So cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, understood? Now a question, half comma half be a direction cosines of vector. To prove it, we have to look at this plus. So look at this, 1 by 4, 1 by 4, 1 by 4. So this is the 3 by 4 not equal to 1. So they are not a direction cosine. Okay, understood? Now a numerical. The position vector of P and Q be 1, 1, 2 meter and -1, -1, 3 meter. Find PQ vector, its magnitude, unit vector along PQ vector, DC, angle made by PQ vector with the x-axis. Okay, now look at this figure. Suppose, look at this, this is the point P and this is the point Q. This is the origin O and this is the origin O. Here OP vector is the I cap plus j cap plus 2k cap. And OQ vector, look at this, OQ vector, this equal to minus I cap minus j cap plus 3k cap. Now look at this, from triangle of vector addition, this vector plus this vector equal to this vector. So PQ vector plus OP vector, this equal to OQ vector. Therefore PQ vector is equal to, this is the this minus this. Okay, so PQ vector is the OQ vector minus OP vector. So look at this minus this. So this is the minus 2x, this minus this is the minus 2y, this minus this, minus 2j, this minus this is the k cap. Okay, now magnitude of PQ vector. So look at this, the magnitude of PQ vector is equal to root under of this square plus this square plus this square. So this is the minus 2, this is the minus 2 plus 1 square. Look at this, this is the minus 2 square, this is the minus this is the minus 2 square, this is the 1 square. So look at this, this is the 4 plus 1, so this is the 3 meter. Okay, now unit vector along PQ vector. So look at this, the unit vector along PQ vector, this is the PQ vector. The unit vector along PQ vector is PQ vector divided by its magnitude. So look at this, this is the PQ vector by PQ. So this is the minus 2 by 3 I cap, minus 2 by 3 j cap, plus 1 by 3 k cap. Now what is DC? Look at this, minus 2 by 3, minus 2 by 3, plus 1 by 3 are the DC of PQ vector. Now angle made by PQ vector with the x-axis. Look at this, here cos alpha is equal to minus 2 by 3. So alpha equal to cos inverse minus 2 by 3. Okay, understood? Now next. Now we have to find expression of displacement vector, velocity vector and acceleration vector in a plane. Okay, suppose a particle moves along this line. The initial position of the particle is p equal to r vector and q equal to r dash vector with respect to the origin. Now look at this, the displacement vector is the linear distance between p and q. So look at this, this is the delta r vector. So r vector plus delta r vector equal to r dash vector. Now delta r vector equal to r dash vector minus r vector. Okay, as the particle moves in a plane, so r has x and y component. Suppose r vector be x, suppose r dash vector be x dash I cap plus y dash j cap and r vector be x I cap plus y j cap. So look at this, here x dash minus x, this is the I cap, plus y dash minus, here y dash minus y, this is the j cap. Now this is the delta x I cap plus delta y j cap. Okay, now velocity vector v vector equals to delta r dash by delta t. So this is the delta x by delta t I cap plus delta y by delta t j cap. Now look at this, this is the vx I cap plus vy j cap. Okay, in calculus v vector becomes dx by dt I cap plus dy by dt j cap. This velocity is called instantaneous velocity. Okay, now acceleration a is equal to delta vx by dt. Now acceleration a vector equal delta vx by dt I cap plus delta vy by dt j cap. In the same way, now instantaneous acceleration a vector equal to dvx by dt I cap plus dvy by dt j cap. Okay, now a numerical. Look at this, 4.20. The position vector of a particle is 3t I cap plus 2t square j cap plus 4k cap meter. Now we have to calculate velocity vector and acceleration vector and magnitude and direction of velocity vector and acceleration vector at t equal to 2 seconds. Now look at this, the velocity vector v vector is the dr vector by dt. So look at this, the differentiation of t is 1 and differentiation of t square is 2t and differentiation of constant is 0. So look at this, this becomes 3 into 1 I cap plus 2 into 2t j cap plus 0. So v vector becomes, look at this, this is the 3 I cap plus 4t j cap. Okay, again acceleration. Now acceleration is the rate of change of velocity with respect to time. So look at this is the constant 0 and this is the 4 into 1 j cap. So acceleration equal to 4 j cap meter per second square. Okay, now magnitude and direction of velocity and acceleration at t equal to 2 seconds. Look at this, v vector at t equal to 2 seconds 3 I cap plus 4 into 2 j cap. So this is the 3 I cap plus 8 j cap. Now magnitude of velocity is equal to 3 square plus 8 square. So look at this is the 9 plus 64. So this is the 73. Okay, meter per second. Now angle made by velocity vector with the x-axis phi equal to, this is the tan inverse coefficient of j by coefficient of I. Okay, understood? Now acceleration. Now magnitude of acceleration is 4 meter per second square directed along y-axis. Okay, understood? Next. Now equation of motion of a particle in a plane. Look at this. Here r vector is equal to x I cap plus y j cap. Velocity vector v equal to, this is the vx I cap plus vy j cap, and acceleration vector, this is the ax I cap plus ay j cap. Okay, now position vector r equals to r naught plus u vector t plus, this is the half a vector, this is the t square. If we resolve this along x and y direction, this can be written as x equals to x naught plus ux into t plus half into ax into t square. In the same way, y equal to, this is the y naught uy into t plus half into ay into t square. Okay, look at this, velocity vector v vector equal to u vector plus a vector into t. Now this can be written as, this is the vx equal to ux plus ax into t, and along y-axis vy equal to uy plus ay into t. Okay, so we consider the motion of the particle along x and y direction separately. Okay, now a numerical. Now this is a very important conceptual numerical. A particle moves along xy plane with initial velocity 10 j cap meter per second and acceleration a equal to 8 I cap plus 2 j cap meter per second square. We have to calculate the time when the particle reaches x equals to 16 meter. And we also calculate the position of the particle along y-axis and velocity vector and speed of the particle. First of all, consider the motion along x-axis. Look at this, x equal to, this is the uxt plus half ax into t square. Now look at this, here x equal to 16 meter. Acceleration equal to 8 meter per second square and initial velocity ux equal to 0. So look at this, 16 equal to 0 into t plus half into, this is the 8 into t square. So look at this is the 16 equal to 4t square. Therefore t equal to root under of 4. Therefore t equal to 2 seconds. Therefore after the time 2 seconds, the particle reaches x equals to 16 meter. Now we have to calculate the y coordinate. Look at this, y equal to, this is the uyt plus half into ay into t square. Now what is uy? Uy equal to t, ay equal to 2. So look at this is the 10 into 2 plus half into, look at this, acceleration along acceleration along y-axis is 2 into 2 square. So 20 plus, look at this is the 4. So this is the 24 meter. So position of the particle along y-axis is 24 meter when the particle along x-axis is 16 meter. Now velocity. Look at this Vx. This is the ux plus ax into t. Ux equal to 0. So 0 plus 8 into 2, that is 16 meter per second. Vy equal to uy plus ay into t. What is uy? Look at this. This is the 10 plus ay. This is the 2 into 2. So this is the 14 meter per second. Look at this velocity v vector equal to, this is the 16 I cap plus 14 j cap meter per second. The magnitude of velocity, that is speed, this equal to 16 square plus 14 square. So look at this. This is the 256 plus 196. So this is the 452 meter per second. Okay, understood? Now next. Now a relative motion of a particle. The velocity of a particle with respect to another particle is called relative velocity of first with respect to second. Suppose first particle moves with velocity va vector and second particle moves with velocity vb vector. So relative velocity of A with respect to B is VAB vector is equal to VA vector minus VB vector. So relative velocity is the vector subtraction of two velocities. Okay, now look at the figure. Suppose the particle A moving along this direction with velocity A and particle B moves with velocity VB vector. Now the relative velocity of A with respect to B, that means the velocity of A should be 0 by producing VB in opposite direction. Look at this. This is the minus VB. Okay. So look at this. The resultant of VA and minus VB is the relative velocity of A with respect to B. This is the VAB vector equal to VA vector minus VB vector. Okay. Now the relative velocity of B with respect to A is obtained by producing VA in opposite direction by minus VA. Now the resultant of minus VA and VB is the relative velocity of B with respect to A. So this is the VB vector. So this is the VA vector equal to VB vector minus VA vector. Look at this. VAB vector is opposite to VBA vector, but they have same magnitude. Now look at this. VAB is equal to VA vector minus VB vector. Therefore VAB this equal to root under of VA square plus VB square minus 2VA VB cos theta. Okay, angle made by relative velocity with respect to A. Look at this. If this is phi, this also phi. So look at this here, 10 phi. This becomes VB sin theta whole divided by VA minus VB cos theta. Okay, understood? Now we solve an important numerical of ncert. When a ship is at rest when flowing at a speed of 72 km per hour and flag of the ship flutters along northeast direction, that is the wind moving along northeast direction. Look at this. This is the east and this is the north. So this is the northeast direction. Okay. Now the ship moves along north with speed of 51 km per hour. So look at this. This is the V2 and this is the V1. angle between V1 and V2, this is the 45 degree. Now we have to calculate the direction of flag flutters. Now the relative velocity of wind with respect to the ship, look at this is the minus V2. Look at this is the V1 and this is the minus V2. So relative velocity is directed along this direction. Okay. So this is the v.r.to vector. This is the v1 vector minus v2 vector. Suppose this angle is phi. So look at this. This is the tan phi. This equal to, this is the 72 sine 45 degree divided by 51 minus 72 cos 45 degree. So look at this is the 36. Now look at this is the 72 into 1 by root 2 and this is the 51 minus 72 1 by root 2. So look at this is the 36 root 2 and this is the 51 minus 36 root 2. Okay, look at this is 51 divided by 51 minus 51. So this is the infinity. So this is the 90 degree. So phi is equal to 90 degree. Now when appear to move 90 degree with the south, that is along the east. So the direction of flag flutters along the direction of east. Okay, understood? Now next. Now relative velocity of rain with respect to a man. Suppose a person moving in a horizontal path with a velocity vm vector. The rain is falling vertically. So relative motion of rain with respect to the man. Look at this. If we produce vm in opposite direction, so the person will be raised at this point. So the relative velocity of rain with respect to the man is directed the diagonal of this parallelogram. So look at this is the diagonal. So rain appears to come in this direction. So to save from rain, person should hold his umbrella in this direction. Okay, in this direction. Therefore, the angle made by umbrella with the vertical direction. Look at this. This is the 10 phi. So this is the Vm divided by Vr. Okay, and relative velocity Vrm vector is equal to Vr vector minus Vm vector. Therefore, Vrm, this is equal to root under of, this is the Vr square plus Vm square. Okay, understood? Now a numerical. Now look at this ncert 4.12. Here an woman moving along this direction with velocity 10 meter per second. Rain is falling vertically 30 meter per second. Find the direction in which he hold the umbrella to save herself. If phi be the angle made by the umbrella with the vertical, then 10 phi equal to Vm by Vr. So here Vm equal to 10 and Vr equal to 30. So look at this here 10 phi equal to 1/3. So phi equal to 10 inverse 1/3. So this is almost 18 degree. So angle made by the umbrella with the vertical is 18 degree. Okay. Now next. Now look at this river crossing. Suppose this is a river of with small d. And it is flowing along this direction. The velocity of stream is u along this direction. A person wishes to cross a river along this direction. This is the point B. Now suppose person steers along this direction with velocity v at an angle theta with the upward bank. Look at this river flowing along this direction. So this is the upward bank and this is the downward bank. Now the component of velocity of v along this direction, this is the v cos theta, and this is the v sin theta. Look at this component help the person to cross the river. So time to cross the river t equal to d by v sin theta. Okay, now look at this. The resultant velocity of the person in the direction of stream is equal to u minus v cos theta. So drift bc is equal to, this is the resultant velocity of the person in the direction of stream into time to cross. This is the t. So look at this, u minus v cos theta into d by, this is the v sin theta. Okay, understood? Now minimum time to cross the river. Look at this, the time t equal to d by v sin theta will be minimum. Look at this, t becomes minimum if theta equal to 90 degree. If theta 90 degree, so sin theta equal to 1, so minimum time is d by v. Okay, now in this case drift bc equal to u minus v cos 90 degree into d by v sin 90 degree. Now v sin 90 means v. So look at this is the u into d divided by v. So drift equal to u into d divided by v when the person crosses the river in minimum time. Look at this, if v cos theta equal to u, then person reaches directly the point B. So look at this, the condition to reach the directly opposite point, this is the v cos theta equal to u. Therefore cos theta equal to u by v. Okay, this is the condition to reach the directly opposite point. Now time to reach the directly opposite point or crosses the river in shortest distance. So this is the t equal to d by, look at the v sin theta. Now sin theta means 1 minus cos square theta root under. So d by v into root under 1 minus u square by v square. So this is the d by root under of v square minus u square. Understood? Okay. If v less than u, person never reaches the directly opposite point. In this case, the drift become minimum if cos theta equal to v by u. Okay, and minimum drift can be obtained by applying this condition in the formula bc equal to, this is the u minus v cos theta into d by, this is the v sin theta. Okay, understood? Now a numerical. Look at this, ncert 4.13. A person wishes to cross a river of with 1 kilometer, steers normal to the direction of stream of 3 km per hour. The speed of the person is 4 km per hour in still water. So look at this, here time to cross the river t equal to d by v sin theta. Okay, where theta is the angle. Now here theta equal to 90 degree, so this is the 1 by v is equal to 4 and sin 90 degree. Okay, so this is the 1 by 4 hour. Now drift, suppose the person reaches from A to C, so drift become BC. So look at this, BC equal to resultant velocity along the direction of stream. So this is the u minus v cos theta resultant velocity into time to cross. Time to cross is the 1 by 4 hour. Look at this, u equal to 3 minus 4 into cos 90 degree, and this is the 1 by 4. So this is the 3 by 4, that is 0.75 kilometer is the drift of the person. Suppose this is a tower of height h. A particle is projected from this point horizontally with velocity u. So look at this, the component of velocity in vertical direction is u cos 90 degree. Okay, and acceleration due to gravity in the downward direction is g, and no acceleration in the horizontal direction. So look at this, acceleration along this direction, velocity along this direction. So nature of the trajectory of the particle is parabola. So the trajectory like this. Here r is the horizontal distance covered by the particle, is the range. If capital T be the time of fall, then h equal to, look at this, this is the half g t square. So t equal to root under 2h by g. Okay, and horizontal range capital R equal to, this is the u into t, that is u into 2h by g. Now we have to calculate the velocity at the final point. Look at this, the velocity at the final point Vx is equal to u, and vertical component velocity Vy equal to g into t, where t equals to root under 2h by g. Angle made by the velocity vector with the vertical is phi. Then look at this, this is the tan phi equal to, this is the Vx by Vy. So look at this, here Vx equals to u and this is the gt. Okay, understood? Now next, look at this, a particle is projected with 10 meter per second horizontally from a tower of height 20 meter. Find time of fall, horizontal range and velocity vector at the final point. Look at this, the tower of height 20 meter. The particle is projected horizontally with velocity 10 meter per second. So look at this, the trajectory becomes this. Okay, now we have to calculate the time of fall. Now this is the height h and this is the velocity u. Suppose time of fall is capital T. So look at this, h equal to, this is the half g t square. So t here root under 2h by g. Look at this, this is the 2 into 20 and g 10. So look at this, this is the 2 seconds. So time of fall is equal to 2 seconds. What is the horizontal range? Horizontal distance r equal to horizontal component of velocity into time. So look at this, here r equal to u into t, u 10 and t 2. So this is the 20 meter. Okay, now velocity vector. Suppose, look at this, this is the x-axis, this is the y-axis. So look at this, here velocity vector v vector equal to vx I cap plus vy j cap. Now look at this, vx same. Now vx is equal to 10 meter per second, that is horizontal component of velocity. So this is the 10 meter per second I cap. Now vertical component, look at this, vertical component is g into t, g equal to 10 and t equal to 2. So this is the g into t and this is the minus j cap. So look at this, v vector becomes 10 I cap minus 10 into 2 j cap, that is 10 I cap minus 20 j cap. Okay, understood? Now projectile motion from the ground. A particle of mass m projected with velocity u at an angle theta with the horizontal. So component of velocity along this direction is u cos theta, that is the initial component of velocity along horizontal direction, and vertical component of initial velocity uy equal to, this is the u sin theta. Okay, now horizontal velocity remain constant throughout the journey as there is no acceleration in this direction. So ux equal to u cos theta equal to vx. So, and the vertical component of velocity vy changes with time, that is u sin theta minus gt. Due to these two velocity, the trajectory of the particle like this. Okay, now this point is the maximum height, so this is the hm. At the top point of the journey, that is the position at maximum height, the body has only horizontal component of velocity, that is this is the u cos theta, and vertical component of velocity, look at this, vy is equal to 0. Now at any point, look at this, at this point horizontal component of velocity u cos theta and vertical component of velocity vy equal to u sin theta minus gt. So angle made by the velocity vector, look at this, this is the phi. So tan phi is equal to this Vy divided by Vx. So look at this. This is the u sine theta minus gt divided by this is the u cos theta. Therefore, look at this, phi equal to tan inverse. This is the u sine theta minus gt by u cos theta is the instantaneous angle made by the velocity vector at any instant t. At this point, phi equal to 0 degree. Okay. Now, equation of motion of the particle. Look at this, along this direction, look at this, x equal to, this is the u cos theta into t. And vertical direction, y equal to, this is the u sin theta into t minus half g t square. So look at this, the position vector r vector equal to, this is the x I cap plus y j cap. So this becomes u cos theta into t I cap plus u sin theta into t minus half g t square. This is the j cap. Okay. Now velocity vector, this is the u cos theta, this is the I cap plus u sin theta minus gt, this is the j cap. Understood? Now next. Now total time of flight. The time required by the particle to reach from this point to this point is called total time of flight. So in total time of flight, the vertical height ascended by the particle is equal to 0. So look at this, when t equal to total time of flight capital T, then y equal to 0. Now look at this, this is the y and this is the y. Now putting the value of y in this equation, this is the u sin theta into capital T minus half g t square. Therefore t equal to 2u sin theta divided by g is the total time of flight. Now horizontal range. Horizontal range is the horizontal distance between initial point and final point. Now look at this, here r equal to, this is the u cos theta into t. Now u cos theta and t means 2u sin theta divided by g. Okay. Therefore u square, this is the 2 sin theta cos theta divided by g. So look at this, this is the u square sin 2 theta divided by g is the horizontal range of the particle. Okay. Now maximum horizontal range. Look at this, r becomes maximum when sin 2 theta equal to maximum. That is sin 2 theta equal to 1. Therefore r max becomes, look at this, r max, this is the u square by g, and sin 2 theta equal to 1, so 2 theta equal to 90 degree, therefore theta 45 degree. So when theta 45 degree, range becomes maximum. Okay. Then we know sin 2 theta and sin 2 into 90 degree minus theta are equal. Therefore horizontal range at the angle of projection theta and 90 degree minus theta are equal. That is horizontal range at an angle of 37 degree is same as horizontal range at angle 53 degree. In the same way, the horizontal range in 10 degree is same as horizontal range at 80 degree. Now look at this, the figure. Suppose this is the, look at this is the angle of projection, this is the 10 degree. Okay. And now look at this is the 80 degree. Okay. This angle of projection 80 degree and this is the 10 degree. Their trajectory are different but horizontal range are same. Okay. Now maximum height. At the maximum height, the vertical component of velocity 0. Now the vertical component of velocity, now Vy square, this is the u sin theta whole square minus 2gy. So look at this, when y equal to maximum height hm, Vy is equal to 0. So look at this, 0 square equal to u square, this is the sin square theta minus 2ghm. So maximum height hm is equal to u square sine square theta divided by 2g is the maximum height. Okay, now we have to derive the ratio between 4 into maximum height. Look at this, 4 into maximum height divided by horizontal range. Look at this, 4 into maximum height. So look at this, this is the 4 into u square, this is the sine square theta divided by 2g, and here this is the u square sine 2 theta, u square sine 2 theta divided by g. Now u square cancel, g cancel. Okay, and 2 4 2. So now look at this here 4hm divided by capital R, this equal, look at this here 2 sine square theta, look at this 2 sine square theta divided by sine 2 theta. Sine 2 theta means 2 sine theta cos theta. So look at this, this is the 2 sine theta into cos theta. So look at this, this is the tan theta. Okay, therefore 4hm by r is equal to tan theta. Now equation of trajectory. Suppose a particle reaches the point px, y in time t. So look at this, the vertical height ascent is y and horizontal distance is x. So look at this here, x equal to u cos theta into t, therefore t equal to x by, this is the u cos theta. Now the vertical height ascent by the particle y equal to, this is the u sin theta into t minus half g t square. If we eliminate t from this and this equation, we can get the equation of trajectory of the particle. So look at this here, this is the u sin theta and t equal to x by u cos theta minus half g and t square, so x by u cos theta whole square. Okay, therefore y equal to x tan theta minus, this is the g x square divided by 2 u square cos square theta is the equation of trajectory. Now we can express the equation of trajectory in the simpler form. Look at this, if look at this here x tan theta and this equals to 1 minus here g x square divided by 2 u square cos square theta into x tan theta. Okay, now look at this here, y becomes x tan theta into 1 minus, look at this, x cancel out, so x divided by, this is the sin theta by cos theta, x divided by 2 u square sin theta cos theta divided by g. So look at this, this is the horizontal range capital R. So here y equal to x tan theta into 1 minus x by r is the is also the equation of trajectory of the projectile. Look at this equation or this equation is the equation of parabola. So equation of trajectory is parabolic. Okay, now ncert numerical 4.31. A particle is projected with velocity vo at an angle theta with the horizontal. After the time t, the velocity vector makes an angle phi. We have to calculate the angle in terms of maximum vertical height and horizontal range. Now look at this, at this point tan phi, this is the vertical component of velocity by horizontal component of velocity. Now vertical component of velocity, if this is the v0 sine, this is the v0 sine theta minus gt divided by v0 cos theta. Okay, now v0 can be written as, look at this, v0 y minus gt and v0 cos theta can be written as v0 x. Okay, now here phi is equal to tan inverse, this is the v0 v naught y, tan inverse v naught y minus gt divided by v naught x. Okay, and now we have to derive the relation between hm, r and theta. Look at this, 4 hm by r. So look at this, this is the 4 into u square sine square theta divided by 2g, and this is the u square sine 2 theta divided by g. Now this cancel, this cancel. So look at this become 4 sine square theta by 2 divided by sine 2 theta. So look at this, here 4 hm by r, this equal to 2 sine square theta divided by 2 sine theta cos theta. So this equal to tan theta. Therefore look at this, theta equal to tan inverse 4 hm by r is the required relation. Okay, now next. The height of the ceiling of a hall is 25 meter. A ball is projected with 40 meter per second. We have to calculate maximum horizontal range without hitting the wall. So look at this, we have to calculate r. So first of all, we have to calculate the angle of projection theta. Look at this, hm, this equal to, this is the u square sine square theta by 2 into g. Look at this, this is the 25 and this is the u square, so this is the 40 square, and this is the sine square theta by 2 into 10. Here sine square theta, this equal to, this is the 20 into 25 divided by, this is the 40 into 40. Now this and this cancel out. And look at this, this is the 5 and this is the 8. This is the 5 by 16. So here sin theta equal to root 5 by 4. There, now sin theta equal to perpendicular by hypotenuse. Now perpendicular 5, hypotenuse 16. So base is root over 11. Now tan theta equal to root 5 divided by under root of 6 4 square minus 5. So look at this, this is the 5 by root under 11. Okay, now we know 4 hm divided by r equal to tan theta. So look at this, r equal to 4 hm into cot theta. So look at this is the 4 into 25 and cot theta equals to root under 11 divided by 5. So look at this is the 100 into root under 11 by 5. So this becomes almost 148.5 meter. Okay. Now ncert 4.16, and throw a ball maximum horizontal distance of 100 meter. If we throw in a vertically upward direction, what height the ball will ascend? Now look at this, the maximum horizontal range, this is the u square by g and this is the 100 meter. Okay. Now we have to calculate the maximum vertical height, this is the u square by 2g. So look at this, half into, this is the 100, so this is the 50 meter. Okay. Understood? Next, look at this, the horizontal range of a bullet is 3 km when angle of projection 30 degree. Can the bullet hit a target at a distance of 5 km from it? Now we know the maximum horizontal range capital R, this equal to u square sine 2 theta divided by g. So look at this, r equal to u square sine, this is the 2 into 30 degree, so 60 degree divided by g. So this is the u square root 3 by 2 into g. Therefore u square by g, this is the 2 by root 3 into r. Okay. Now maximum horizontal range r max, this equal to u square by g, and this is the 2 into 3 km divided by root 3. So 6 by root, so look at this, 6 by root 3, that is 2 root 3 km, that is 3.4 kilometer almost. So maximum horizontal range 3.4 kilometer. So bullet can't hit a target at a distance of 5 kilometer from the point of projection. Okay, understood? Next, look at this. A fighter plane moving with a velocity of 200 meter per second. A bullet is projected 600 meter per second to hit the fighter plane. Find angle of projection with the vertical to hit the target. Now next question, find the minimum height of the fighter plane so that the bullet can't hit the fighter plane. Now first of all, look at it. The bullet hits the fighter plane if the horizontal component of velocity 600 sine theta is equal to velocity of the fighter plane. So bullet hit that fighter plane if 600 sine theta this equal to 200. So sine theta this equal to 1/3. This is sine almost 20 degree. Therefore theta equal to 20 degree. So angle made by the bullet with the vertical is 20 degree. Now what is the minimum height of the fighter plane such that bullet can't hit the fighter plane? Now minimum height of fighter plane is equal to maximum height ascent by the bullet. Now maximum height ascent by the bullet, this is the hm, so this is the u square, this is the cos component, so this is the cos square 20 degree divided by 2 into 10. So look at this is the 36000 into cos square 20 degree, this is the 0.94 whole square divided by this is the 20. This and this cancel out, and so this is almost 600 meter, that is 16 kilometer. Therefore the minimum height of the fighter plane should be 16 kilometer. Now circular motion. If a particle rotates in a circular path, then the motion is called circular motion. In circular motion, the velocity of the particle changes at every point because direction of velocity is directed tangentially. Now radius of the circular path is called radius vector, and a line passes through the center of the circular path and normal to the plane of the motion is called axis. In circular motion, axis always fixed as direction in linear motion. Now angular displacement. The angle made by the rotating body at the center of the circular path is called angular displacement. The angular displacement of finite value is a scalar quantity, but angular displacement of very small value is a vector quantity because it obeys the commutative law of vector addition, that is delta theta 1 plus delta theta 2 vector sine is equal to delta theta 2 plus delta theta 1. Okay, understood? The unit of angular displacement is radian. In one complete rotation, the angular displacement is 2 pi. Now time period. The time required to complete one rotation is called time period and it denoted by capital T. So in one time period the angular displacement is 2 pi. Now frequency. The number of revolution per second is called frequency. So if f number revolution takes place in 1 second, so for one revolution this is the 1 by f second, so 1 by f equal to t. So time period is the inverse of frequency of revolution. Okay, the unit of frequency is per second, that is revolution per second. RPM, revolution per minute. Okay, now we have to establish the relation between linear displacement and angular displacement. Look at this. This is the arc length. So the theta equals to arc length by radius. So S equals to r theta is the relation between the linear displacement and angular displacement. Okay. Now angular velocity. The rate of change of angular displacement with respect to time is called angular velocity. The angular velocity omega equal to theta by t, or instantaneous angular velocity omega equals to d theta by dt. Understood? Its unit is radian per second and dimension t minus 1. Okay? When small t equal to capital T, that is 1 period, the angular displacement is 2 pi. Okay? So in this case, t equals to 2 pi by t equals to 2 pi, 1 by t equals to a frequency equals to 2 pi into RPS equal to 2 pi into RPM divided by 60. Okay? Understood? The time period of minute hand of a clock is 12 hours. So angular velocity of minute hand is 2 pi by 12 radian per hour. The time period of rotation of earth is 24 hours. So angular velocity of rotation of earth is 2 pi by 24 radian per hour. Okay? Now we have to establish the relation between linear velocity and angular velocity. Look at this. We know S equals to r theta. Now dividing by time t, t equal to r into theta by t. So look at this. Here S by t equal to v and r. This is the omega. So v equal to r omega. In vector form, v vector equal to omega vector cross r vector. Okay? A flywheel rotates at 300 rpm and its diameter is 20 cm. Find period, angular velocity and linear velocity at the tip of its edge. Look at this. Look at this. Here frequency is equal to 300 rpm. Okay. Now this becomes 300 by 60 rps. Okay. So this is the 5 rps. Okay. Now time period t equals to 1 by f. So this is the 1 by 5 second. Next omega, this equals to 2 pi by capital T is equal to 2 pi divided by 1 by 5 equal to 10 pi radian per second. Okay. Now the linear velocity. We know the linear velocity capital. Now the linear velocity v equal to omega into r. Now omega equals to 10 pi. This is the radian per second and r equals to, look at this. This is the diameter. So radius is equal to 10 centimeter. That is 0.1 meter. So velocity becomes pi meter per second. Okay. Now angular acceleration. The rate of change of angular velocity with respect to time is called angular acceleration. Suppose initial angular velocity of a particle be omega 1. After the time t, its angular velocity becomes omega 2. So alpha equals to the change of angular velocity omega 2 minus omega 1 divided by time interval. So from this relation we can get, this is the omega 2 minus omega 1 equal to alpha t. Therefore omega 2 equal to omega 1 plus alpha t. Okay. if initial linear velocity be v1, then v1 equal to omega 1 into r, and final linear velocity v2 equal to omega 2 into r, then linear acceleration, this is the v2 minus v1 divided by t, so this is the omega 2 into r minus omega 1 into r divided by t. Okay, now from this relation we can get r into omega 2 minus omega 1 divided by t, so this is the r into alpha. Therefore a linear acceleration is equal to radius into angular acceleration. Okay, now look at this relation is same as that of final velocity equal to initial velocity plus acceleration into time. In the same way, the angular displacement theta equal to omega 1 t plus half alpha t square. Okay, just as this relation same as the s equals to ut plus half a t square. In the same way, look at this, omega 2 square equal to omega 1 square plus 2 alpha theta. This relation is same as b square equal to u square plus 2as. Okay, now a numerical. The angular velocity of a particle about O is 10 radian per second. Now we have to calculate the angular velocity about the point A. Now look at this, if this angle is theta, so now a line is drawn here, this angle is theta by 2, this is the phi, because angle at circumference is half the angle at the center. So look at this, here phi equal to theta by 2. Now angular velocity omega dash is the d phi by dt, this equal to half into d theta by dt. Now here angular velocity about center, that is d theta by dt is given, so this is the half into 10, so this is the 5 radian per second. Okay, so angular velocity about the point on the circumference is 5 radian per second. Okay, next, now a important numerical. An electric fan completes 10 revolutions in first 5 seconds. Find number of revolution completes in next 5 seconds. Also find its angular acceleration, linear acceleration at the tip if its length is 0.5 meter. As electric fan is initially at rest, so omega 1 equal to 0. Now theta equals to omega 1 into t plus this is the half alpha t square. So look at this, here theta equals to 20 pi and this is the 0 plus half into alpha and this is the 5 square. So look at this, alpha is equal to 40 pi divided by 25. So this is the 4 into 40 pi divided by 4 into 25. So look at this, this is the 1.6 pi. Okay, the number of revolution completes its next 5 seconds. So to calculate the number of revolution completes its next 5 seconds, we have to calculate the displacement in total 5 seconds plus 5 seconds 10 seconds. So look at this, in 10 seconds theta equals to half into alpha, alpha means 16 pi into t square, that is 10 square. So look at this, this is the 0.8 pi into 100, so this is the 80 pi. Therefore number of revolution n equals to theta by 2 pi, so this equal to, this is the 40 revolution. Now look at this, in first 5 seconds number of revolution is 10. In first 10 seconds the number of revolution 40. Now the next 5 seconds the number of revolution becomes 40 minus 10, that is 30. Okay, Understood? Now a linear acceleration at the tip. We know a equal to r into alpha. Here alpha equal to 1.6 pi and r equals to, this is the 0.2, so this is the 0.32 pi meter per second. Okay, understood? Now centripetal acceleration. When a particle rotates in a uniform circular motion, the acceleration along the radius towards the center of the path is called centripetal acceleration or radial acceleration. Look at this. Suppose this is the center of the circular path. Okay. Now a particle rotates along this direction. So look at this. At this point, the velocity directed tangentially, this velocity v1 vector. Now at this point, the velocity directed v2 along this direction. So acceleration is equal to v2 vector minus v1 vector divided by time, and this acceleration is directed along this direction, and magnitude of acceleration is v square by r or omega square into r. Now we have to derive this acceleration. Now look at this. Suppose position A and B, this angle is very small angle theta. So look at this, acceleration A equal to, this is the magnitude of change of velocity divided by time. Okay. Now what is the magnitude of change of velocity? Look at this. This is the v2 square plus, this is the v square plus, this is the v square plus v square minus 2v into cos theta divided by time t. Now look at this. This is the 2v square minus 2v square cos theta. So look at this, root under of 2v square into 1 minus cos theta divided by time t. So look at this, 2 cos theta means 2 sine square theta by 2. So here we get 4 v square sine square theta by 2 divided by 1 by t. So look at this, this is the 2v sine theta by 2 divided by t. For small value of theta, sine theta by 2 is equal to theta by 2. Therefore acceleration is 2v into theta by 2 divided by t. Therefore v theta by t. So this is the v into omega. Now omega equal to v by r. So this is the v square by r is the acceleration. Okay. Therefore A equal to v square by r equal to omega square r square by r, that is omega square into r, is equal to omega square into r. This is the centripetal acceleration. Now look at this graphically, the direction of acceleration. Look at this here, look at this here. Now look at this here, velocity vector along this direction. Here velocity vector along this direction. So look at this, this is the v1 vector, this is the v2 vector. So look at this, this represents the v2 vector minus, so this line represents the v2 vector minus v1 vector. This is the center of the circular path. Okay. Now this direction towards the center of the circular path. Okay. So this acceleration is radial acceleration. Now if the particle rotates with non-uniform velocity, then the particle also has an acceleration. This acceleration is known as tangential acceleration, at. This is the dv by dt, and this acceleration is directed towards the tangent to the path, that is, this is the dv by dt. Now look at this. So in a circular path, centripetal acceleration, this is the v square by r, and tangential acceleration dv by dt along this direction. Suppose this is the net acceleration. So net acceleration, this is the root under of v square by r whole square plus dv by dt whole square. Okay. If this angle phi, that is resultant acceleration, makes an angle phi with the tangent of the circular path, then look at this here, tan phi is equal to v square by r divided by dv by dt. Okay. Understood? Now we solve some numericals of ncert. A stone is tied by a string of length 80 centimeter and it revolves and it completes 40 revolutions in 25 seconds in a horizontal circular path. Find its acceleration and its direction. Look at this. Here frequency is equal to 14 by 25 is constant. So it is uniform circular motion. That is, its speed is constant. So the stone has only one acceleration, that is centripetal acceleration, and it is directed radially inward, that is towards the center of the circular path. Now look at this. So this acceleration is omega square into r. Now omega is equal to 2 pi f whole square into r. So this is the 4 pi square and f is the 14 by 25 whole square and this is the 0.8 meter per second square, and this almost equals to 9.9 meter per second square. Okay, understood? Next. Now an aeroplane loops a loop of radius 1 kilometer, that is 1000 meter, with a speed 900 km per hour. We have to calculate the centripetal acceleration and ratio between centripetal acceleration and acceleration due to gravity. So look at this. Here velocity v equal to 250 meter per second. So what is the expression of centripetal acceleration? Look at this. This is the a equal to v square by r. So look at this. This is the 250 whole square r equals to this is the 1000. So look at this, 62500 and this is the 00. This cancel out. So this is the 62.5 meter per second square is the centripetal acceleration of the aeroplane. Now look at this. The acceleration due to gravity is 9.8. So this becomes, look at this, 62.5 divided by 9.8. So here a equal to 6.3 g. That is 6.3 times the acceleration due to gravity. Understood? Now next. Now in a circular path of radius 80 meter, a cyclist moves 27 km per hour and its velocity reduces at the rate of 0.5 meter per second square. We have to calculate the net acceleration of the cyclist and its direction. As the cyclist moves with variable velocity, so it has two acceleration. One is centripetal acceleration AC is equal to v square by r and other is at equal to this is the dv by dt. So look at this. Suppose this is the circular track and look at this. This is the velocity acceleration dv by dt and this is the v square by r. So net acceleration directed along this direction. This is the a and this angle phi. We have to calculate dv by dt, v square by r, a and phi. Okay, now look at this. First of all, centripetal acceleration AC. What is the v? Look at this, v equal to 7.5 meter per second. So here 7.5 whole square divided by 80. This is almost equal to 0.7 meter per second square. Now the tangential acceleration dv by dt is given. So net acceleration a equal to, look at this, d square plus d square under root. So look at this. This is the 0.7 whole square plus this is the 0.5 whole square. So look at this. This is the 0.49 and this is the 0.25. So look at this. This is the 0.74. Okay, and this equal to almost 0.86 meter per second square. Now angle made by the acceleration vector with the direction of velocity. So phi equal to 10 inverse. Look at this by this. So this is the 0.7 divided by 0.5. So this is the 10 inverse 1.2. This is almost 56 degree. Okay, understood? Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, Main and Advanced. Please like, share and comment on this, and if you are new, don't forget to subscribe my channel to get the important video for you.